Okay. So, hi everyone. So, first of all, let me know, is my video and audio clear here? Is the video and audio clear? Yes? So, is my audio and video clear here? Is audio and video clear? Yes or no here? Is my audio and video clear here? Let me know in comment section. Is it clear? So in the previous sessions, we have started rectangular coordinate system, and also we have completed this cylindrical coordinate system. Yes or no? So in the previous classes, we have completed rectangular coordinate system and cylindrical coordinate system. Okay. So in comment box, let me know here. Let me know, is it clear here? My audio and video, is it clear? Yes or no? Okay. Okay here. So in the previous sessions we have completed the cylindrical coordinate system, and also we have studied rectangular coordinate system. Yes or no? We have completed rectangular coordinate system, and also we have studied cylindrical coordinate system. Yes or no? Okay. So in this session we try to solve some problems here. We try to solve some problems based on this rectangular and cylindrical coordinate systems. Based on this rectangular and cylindrical coordinate systems, we try to solve some problems here. Okay. 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 So in rectangular coordinate system, what we have studied here, we have seen the differential lengths and then differential areas and differential volumes. Yes or no? So what are the differential lengths here? They are nothing but dx ax cap, dy ay cap, and dz az cap. So these are the differential lengths in rectangular coordinate system. And in cylindrical coordinate system here, what are the differential lengths here? What are the differential lengths? That is d rho a rho cap, and then rho d phi a phi cap, and then dz az cap. So these are the three differential lengths in cylindrical coordinate system, and these are the three differential lengths in rectangular coordinate system. Okay. 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 And in this rectangular coordinate system, we have seen the differential areas. Yes or no? We have seen differential areas. So what are the differential areas we got here? So dA1 is equal to what? Is equal to, we got dx dy, it is pointing in az cap direction. So this plane, we call it as what? We call it as z is equal to constant plane. So here the variables are nothing but x and y. Understood? And the direction of the surface is along what? Is perpendicular to this surface, that is along az cap direction. Next, another differential area we got here is nothing but what? Is nothing but dy dz. Its direction is along what? Its direction is along ax cap direction. Next, another differential area we got dA3 is equal to what? Is equal to dz dx into what? Into ay cap. Okay. So this, here the variables are y and z, so we call this as x is equal to constant plane, and here the variables are z and x. Here the variables are z and x, so we call this plane as y equal to constant plane. Okay. So all these things we have seen here. Okay. For z equal to constant plane, the direction is along az cap. For x equal to constant plane, the direction is along ax cap, and for y equal to constant plane, the direction is along ay cap. Understood? Okay. And what is the differential volume here? What is the differential volume we got? Differential volume is equal to what? Is equal to, we got dx, dy and dz. So in case of differential volume, all the three x, y and z are variables. Okay. Okay. Yeah. So now we try to solve some problems here based on this rectangular coordinate system. Then we try to solve some problems based on cylindrical coordinate systems also. Understood? Okay. Okay. Yeah. Okay. So see, please comment something in chat box here. Is audio and video, is everything clear? Yes or no here? Is audio and video everything clear? Let me know here. Okay, clear. Okay, thank you. Okay. Now, okay, so we'll solve some problems here based on this rectangular, and then we'll solve some problems on cylindrical also. Okay. Now, see here. Now, let us consider the charge is distributed. Charge is distributed uniformly. Charge is distributed uniformly along z-axis, and it is given by so that means the distribution of charge is given by, so they have given it as rho L is equal to 10 nanocoulomb per meter square, 10 nanocoulomb per meter square for z varying from 1 to 5, z varying from 1 to 5. Understood? Okay. And rho L is equal to 0 elsewhere rho L is equal to 0. Understood? So they have given the charge is distributed uniformly along z-axis, and that distribution is given by rho L equal to 10 nanocoulomb per meter here, 10 nanocoulomb per meter. Okay. So 10 nanocoulomb per meter in the range of z 1 to 5, and in remaining values of z, rho L is becoming 0. Now here, this rho L is nothing but what here? Rho L is nothing but the charge per unit length. Yes or no? The charge that is distributed per unit length. Here. Okay. So that means here you are having z-axis. Let us say this is z-axis here. Okay. So let us say this is z is equal to 0. Understood? Okay. Now consider here, let us say this point is z equal to 1, and here this is z is equal to 5. So what they are saying is the charge is distributed uniformly. Along z-axis, and this distribution is given in this manner over this range. So before this 1 and beyond this 5, the charge distribution will be 0. Understood? Okay. Okay. So between 1 to 5, the charge is distributed uniformly. So that means what here? Uniform distribution means what? You can go to any unit length here. Between 1 to 5, you can go to any unit length. Understood? So within that unit length, the charge distribution will be same. That means if you go to this location here, at this location, the charge density is 10 nanocoulomb per meter. If you go to some other location here, here also the charge distribution is 10 nanocoulomb per meter. So if you go here also the charge distribution is 10 nanocoulomb per meter. So from z equal to 1 to 5, at each and every location here, the distribution of charge is uniform. Understood? Okay, so below this 1 and above this 5, the charge distribution is 0. Understood? Okay. So now what they are asking here is, determine the total charge. Determine the total charge here. Determine the total charge QT. Determine the total charge QT. Understood? Okay, so how to determine the total charge here? It is very simple here, simple question. Okay, see here. Now if I consider a small differential length here, if I consider a small differential length dl, here, then what is the charge that is going to be present over this small differential length dl here? What is the charge that is going to be present over this small differential length dl? Is nothing but what? Is nothing but rho l into dl or not? Yes or no here? Rho l is nothing but the charge that is present per unit length. Now if you want to determine the charge that is present over this small differential length dl, then the charge that is present over this small differential length dl is nothing but what? Is nothing but rho l into dl. Yes or no? Okay, so the charge that is distributed over a small differential length dl is nothing but rho l into dl. Now if you want the total charge here, that is distributed between 1 to 5, then what you have to do? You have to integrate from 1 to 5 here. You have to integrate from 1 to 5. So that is going to give you what? That is going to give you the total charge. Understood? Now here this dl is nothing but what? The charge is this dl is nothing but what? This dl is along which axis here? It is along z axis. So you can just replace this dl with what? With dz, and here rho l is nothing but what? Rho l is nothing but 10 nanocoulomb per meter, and here z is varying from where to where here? Z is varying from 1 to 5. Now if you observe here, this rho l is independent of what here? Independent of this integration variable. Rho l is independent of this integration variable, so you can take it out of the integration. So if you take it out of the integration, what you are going to get here? So you are going to take rho l out of the integration here, okay, because it is independent of what? Independent of this integration variable z. Okay, so integral z is equal to what? Z is equal to 1 to 5 dz. Understood? So from here what you are going to get here? Rho l is nothing but 10 nanocoulomb per meter. So integral dz is z. Its range is from 1 to 5. So if you substitute this, what you are going to get here? Here 10 nanocoulomb per meter into 5 minus 1 meter. Here meter will get cancelled. So you will get what? 10 into 4, that is 40 nanocoulomb. Understood? Okay, so the charge that is distributed over this length, is nothing but what here? Is nothing but 40 nanocoulomb. Understood? Now here okay, 40 nanocoulomb. Now here, whenever the charge is uniformly distributed here, that is, if you want to determine the total charge along the line, what you have done? Integral rho l dl. Understood? So whenever rho l is constant with respect to integration variable. If rho l is constant with respect to integration variable, okay, which means we can say rho l is uniformly distributed. So if rho l is uniformly distributed, that means rho l is uniformly distributed means what here? This is independent of what? The distribution of charge is independent of what? Independent of length. So everywhere at each and every point along the length, the distribution is going to be uniform. Understood? Then we can treat it as what? Constant with respect to integration variable. Then you can take it out of the integration. You will get what? Simply rho L into integral dl. This is equal to what? Rho L into L. Rho L into L. Understood? So that means whenever the charge distribution is uniform here, whenever the charge distribution is uniform, then you can directly multiply. Then you can directly multiply this charge density with the length here, with the length. Understood? Now here in this problem also, the charge density is how much here? 10 nanocoulomb per meter. Understood? It is distributed over a length from z equal to 1 to z equal to 5. Understood? That means what is the total length here? 5 minus 4, that is 5 minus 1, that is 4. 4 into 10, you will get what? 40 nanocoulomb. That's what we got here or not? Yes or no? So what I am saying here is, whenever the charge is distributed uniformly, then you can directly multiply the charge density with the length. Understood? Okay. Okay, yeah. So now okay. Next example here. Now let us consider rho L. Rho L is equal to 10 by z square. 10 by z square microcoulomb per meter. 10 by z square microcoulomb per meter. Okay, this is the charge density. Or I will give in this manner here. Wait. Okay. So the charge is distributed along z axis, which is given by so rho L is equal to 10 by z square nanocoulomb per meter. Okay, so this is for z varying from 1 to 10. And rho L is equal to 0. Elsewhere. Okay, then determine the total charge. Understood? Okay, so they have given that the charge is distributed along z axis, and the charge distribution is given as what? Is given as rho L is equal to 10 by z square nanocoulomb per meter. So this is the charge distribution that is distributed over a length from 1 to 10. Yes or no? Okay, it is distributed along z axis from z equal to 1 to z equal to 10. So in remaining regions, this charge density is equal to what? Is equal to 0. So that means if you consider z axis here, okay, now here let us say this is z is equal to 1, and here let us say z is equal to 10. Understood? Okay, so now here the charge distribution. Now by seeing this, what we can observe here, the charge distribution along z axis is non-uniformly distributed. Yes or no here? See, if you go to a location z equal to 1 here, z is equal to 1. Understood? What is the charge per unit length that is present at the location z equal to 1 here? That is nothing but 10 nanocoulomb per meter. So at this location, z equal to 1, the charge distribution is 10 nanocoulomb per meter. Now if you go to a location z equal to 2 here, at that location, let us say z is equal to 2 here, at this location let us say z is equal to 2. So at this location here, what you are getting here? 10 by 2 square, that is 10 by 4. So that means here you are having 2.5 nanocoulomb per meter. And similarly, if you go to z equal to 3 location, at this location, what is the charge density here? 10 by 3 square, that is 10 by 9 nanocoulomb per meter. So that means if you observe as you move from z equal to 1 to z equal to 10 here, as you move from z equal to 1 to z equal to 10, the charge density is changing or not? The charge density is changing. So that means the distribution of the charge, along this line is non-uniform, That means the charge is distributed non-uniformly over this length, z equal to 1 to 10. Understood? In the previous case we have seen uniform distribution. Now in this case we are seeing what? Non-uniform distribution. Understood? Okay, so that means here the charge density is a function of what? Is a function of z. It is varying along z. Understood? Okay, so now if you want the total charge here, what we have to do? We have to follow the same procedure here. What is that? Now let us consider a small differential length here. Let us consider a small differential length dl. Understood? So what is the charge that is going to present over this small differential length dl here? See, the charge that is present per unit length is nothing but rho l. If you want to determine the charge that is present over a small differential length dl, that is nothing but what? That is nothing but rho l into dl. So rho l into dl is the small differential charge that is present over a differential length dl, Now if you want the total charge here, then you have to integrate over this length, Yes or no? From where to where you have to integrate? From z equal to 1 to z equal to 10. So below z equal to 1 there is no charge, above z equal to 10 there is no charge. Understood? Okay, so you have to integrate from z equal to 1 to what? Z equal to 1 to z equal to 10. Now here dl, this differential length, this dl is present along which axis here? It is present along z axis. So you can replace this dl with what? With dz. Understood? Okay, yeah. So now here substitute here. What is rho l here? Rho l they have given as 10 by z square. And here z is equal to 1 to what? Z is equal to 1 to 10. dz. So if you do this, what you are going to get here? 10 is constant, take it out of the integration. Okay, so integral 1 by z square here, integration of 1 by z square. What is the integration of 1 by z square here? Is nothing but minus 1 by z. Yes or no? Minus 1 by z. Now its range is from 1 to 10. Yes or no here? Okay, now if you substitute this here, what you are going to get? 10 into, so take minus outside here, so you are going to get minus 10. Now substitute this range here, so you are going to get 1 by 10 minus 1. Okay, so if you do this, what you are going to get? Minus 10. So 1 minus 10, that is minus 9 divided by 10. Okay, so here 10 will get cancelled. Yes or no here? So 10 into 1 by 10 minus 1. Okay, so 1 minus 10 is minus 9 by 10. So here 10 will get cancelled. You are going to get what? You are going to get 9 nano coulomb. Yes or no? You are going to get 9 nano coulomb. Understood? So this is 10 by z square nano coulomb per meter, and this is dz, its units are meter. So meter will get cancelled. So finally you are going to get 9 nano coulomb. So this is the total charge. That is distributed along z axis from z equal to 1 to 10. So how much here? What we got? 9 nano coulomb. Understood? Okay, so is it clear here? Okay. Okay, is it clear here, this problem? Okay, so next problem here, So next example. Okay, see here. Now here let us say the distribution of charge, the distribution of charge on the surface is given by rho s is equal to x y square microcoulomb per meter square, x y square microcoulomb per meter square for x varying from 1 to 5, for x varying from 1 to 5, and y varying from 2 to 5. Understood? Okay, so the distribution of charge on the surface is given by rho s is equal to x y square microcoulomb per meter square, and here x is varying from 1 to 5 and y is varying from 2 to 5. Okay, so this is the charge distribution they have given here, and they are asking to determine the total charge. Determine the total charge. Okay. So if you try to determine the total charge, what you are going to get? Tell me. See here, they said that the distribution of charge. On the surface is given by rho s is equal to x y square microcoulomb per meter square, and the surface is defined as what? Is defined as x is varying from 1 to 5 and y is varying from where to where? Y is varying from 2 to 5. So this is the surface they have defined. Understood? So that means on this surface, what are variables here? X is variable and y is variable. So we can call this plane as what? We can call this plane as z is equal to constant plane. Yes or no? So they have given some z is equal to constant plane. So in that plane, the range of x is from 1 to 5 and the range of y is from 2 to 5. Understood? So now you have to determine what? You have to determine the total charge that is present, that is distributed on this surface. Now here if you observe rho s is distributed along xy plane. Yes or no? Z equal to constant plane means xy plane. So the variables are x and y. Understood? Okay. Now here the charge distribution is xy square. So that means what here? It is uniform distribution or non-uniform distribution? Tell me. So if you substitute the values of x and y here, if you substitute different values of x and y, this charge distribution is going to change or not? Yes or no? So that means they have given non-uniform charge distribution. Understood? Okay. So in this case, if you want to determine the total charge here, what you have to do? So here let us consider this is x axis. Okay. Let us consider this is y axis. Now consider, let us say this is the plane they have given. Okay. So now here x is equal to, let us say x is equal to 1 here and x is equal to 5 here, and this is y is equal to 2 and this is y is equal to 5. So this is the surface they have given. So on this surface they have given the surface charge density. Rho s is equal to what? Rho s is equal to xy square coulomb per meter square. Now you have to determine the total charge here. Understood? Okay. So now if I consider a small differential area here, on this surface. Understood? So what is a small differential area in xy plane here? Is nothing but what? Is nothing but dx dy or not? Yes or no? It is nothing but dx dy. So what is the charge that is present over this small differential area here? So if I consider this differential area as dA, where dA is nothing but dx dy. Understood? Okay. So here what is the charge that is distributed over this small differential area? dA is nothing but rho s into dA. Understood? Okay. So if you want the total charge, that is distributed throughout this surface, then you have to integrate with respect to what? You have to integrate with respect to x, and you have to integrate with respect to y. So now here the differential area is nothing but what? Here this differential area is nothing but what here? It is in xy plane. Yes or no? So rho s into dx into dy. Understood? Now here x is varying from where to where here? X is varying from 1 to 5 and y is varying from 2 to 5. So they have given rho s value. Rho s value is equal to xy square microcoulomb per meter square. Yes or no? Okay. Now solve this integration here. What you are going to get? So x is equal to 1 to 5, y is equal to 2 to 5. Here x y square dx dy. Okay. Now if you substitute this, what you are going to get? Tell me. So you are going to get x square by 2. Its range is from 1 to 5. Integration y square is y cube by 3. So that is from 2 to 5. Understood? Okay. Now if you substitute this, what you are going to get here? Tell me. So here 1 by 2 into x, substitute this ranges here. What you are going to get? You are going to get 5 square minus 1, that is 25 minus 1 into 1 by 3 into 5 cube minus 2 cube. So 5 cube is how much here? 125 minus what? 2 cube. 2 cube is 8. Okay. So you will get 1 by 2 into 1 by 3 is 1 by 6 into 24. Okay. So 125 minus 8 here. 125 minus 8 is nothing but what? 117. Yes or no? 117. So 6 ones, 6 fours. So you will get 4 into 117 nanocoulombs. You will get 4 into 117 nanocoulombs. Okay. So that is the answer for this question here. Understood? So this is the charge that is distributed over this surface area, defined by x and y. Understood? Okay. See, if the charge distribution is uniform, then you can directly determine the total charge as what? Rho s into what? Rho s into total surface area. So when you can do this here? Whenever the charge distribution is uniform, then you can directly multiply rho s into A in order to get what? In order to get the total charge. If the charge is non-uniformly distributed here, throughout the surface, then you have to go for integration like this. Understood? If it is uniformly distributed, then you can directly multiply the given charge distribution with the surface area in order to get the total charge. Understood? Okay. Okay. Next. Is it clear here? Is this problem clear? Yes or no here? Okay. Okay. So next problem here. Write down next problem. See, whenever we are dealing with Gauss law here, so all these things will be very much helpful. Understood? Okay. See, next problem here. Now here the charge distribution throughout the volume is given by rho v is equal to 30 x square y microcoulomb per meter cube. Okay. So this is volume charge density here. They have given as rho v is equal to 30 x square y microcoulomb per meter cube. Okay. And the charge distribution throughout the volume is given by rho v is equal to 30 x square y microcoulomb per meter cube, and the volume is defined by volume, if volume is defined by x varying from 0 to 1, y is varying from 0 to 1, z is varying from 0 to 1. Okay, x is varying from 0 to 1, y is varying from 0 to 1, and z also varying from 0 to 1. Understood? So then so first one here, first problem, then determine the total charge, then determine the total charge qt. Understood? Next, second problem here. In this the second case. Okay, so determine total charge in the above case, if range of y is changed as y varies from -1 to 0, y varies from -1 to 0. Understood? Okay, so this is the question they have given here. What is the question they have given here? The charge distribution throughout the volume is given by rho v is equal to what? Rho v is equal to 30 x square y microcoulomb per meter cube, So and the volume is defined by what? Volume is defined by x is varying from 0 to 1, y is varying from 0 to 1, and z is also varying from 0 to 1. So then in the first case they have asked to determine what? Determine the total charge, and also in the second case what they have asked here? Determine the total charge in the above case if the range of y is changed to what? Is changed to -1 to 0, Understood? Okay, so here what they have given here? The charge that is distributed per unit volume. Yes or no? Here the charge density is nothing but the charge per unit volume. So this is the charge that is distributed per unit volume. So here x is varying from 0 to 1, y is varying from 0 to 1, z is varying from 0 to 1, will form what? Will form a cube, So within that cube, the charge is distributed in this manner. Understood? Okay, so here also this is nothing but what? This is nothing but non-uniform charge distribution or not? This is nothing but non-uniform charge distribution. Yes or no? Because if you vary the values of x and y, the charge distribution is going to change. It is not uniformly distributed. Yes or no? So it is non-uniform charge distribution. Understood? Now if you consider a cube here, you consider a cube like this. Let us assume this is the cube, and here the charge is distributed. Throughout the volume of the cube. Okay, so now if I consider a small differential volume here, dV, then what is the charge that is going to be present over this small differential volume dV here? What is the charge that is going to be present over that small differential volume dV? See, the charge per unit volume is nothing but rho v. Yes or no? That is the charge that is present per unit volume is nothing but rho v. Then what is the charge that is going to be distributed over this small differential volume dV here? Is nothing but what? Rho v into dV. Yes or no? It is nothing but rho v into dV. Now if you want the total charge here, what you have to do? You have to integrate. With respect to what? Here dV means what here? How many variables you are going to have? You are going to have three variables, yes or no, dx, dy and dz. So you have to integrate with respect to what? With respect to x, with respect to y, with respect to z, with respect to x, with respect to y and with respect to z. So that is going to give you the total charge, that is going to give you the total charge, yes or no here. Okay, so here if you do this, what you are going to get here? Qt is equal to, x is varying from where to where? X is varying from 0 to 1, yes or no? X is varying from 0 to 1 and y is also varying from 0 to 1 and okay, and z is varying from 0 to 1 and rho v they have given as 30 x square y, 30 x square y microcoulomb per meter cube. Okay, so remember the units here, microcoulomb per meter cube. So this is rho v, this is rho v, and dv is nothing but dx dy dz, dx dy dz. Okay, okay. TPM, sir, are you from Andhra? Yes sir, I am from Andhra only. Okay, okay. Now see here, now what you are going to get here? So here you have to integrate with respect to x, with respect to y and with respect to z. Now here 30 is constant here, 30 is constant, so take it out of the integration, so 30. Now integral x square dx here, integral x square dx is nothing but what? Is nothing but x cube by 3, its range is from where to where? 0 to 1, 0 to 1. Understood? Next, integral y dy, integral y dy, integral y dy is nothing but y square by 2, y square by 2, its range is from 0 to 1. Next, integral dz, integral dz is nothing but z, its range is from 0 to 1, its range is from 0 to 1. Okay, so now if you substitute the range here, if you substitute the range, what you are going to get? Here you are going to get 1 by 3 and here you are going to get 1 by 2 and here you will get 1. Understood? So here 3 ones and here 3 tens. So 2 ones, 2 5s. Okay, so what you are going to get? What you are going to get? 5 microcoulomb. Yes or no here? The total charge is nothing but 5 microcoulomb. So 30 x square y microcoulomb per meter cube. Here dx dy dz means you have to multiply with meter cube. So the total charge will be in terms of what? In terms of microcoulomb. Understood? So the total charge is nothing but 5 microcoulomb. Okay. Now here in the second case here, in the second case, what they have given here? What they have given? Determine the total charge. Determine the total charge in the above case if the range y is changed from where to where? -1 to 0. -1 to 0. So everything you can keep same here. Everything you can keep same. Okay. Just you have to change what? You have to change the you have to change what? Just you have to change the limits of y. Understood? Okay, everything will remain same here. So here 30 into x cube by 3, 0 to 1. Understood? Here y square by 2. Now here what you have to get? In place of y is varying from where to where now? Y is varying from -1. Yes or no? Y is varying from -1 to 0. Understood? Now just change the limits of y here. It is varying from -1 to what? -1 to 0. -1 to 0. Okay. Now if you do the analysis, what you are going to get? So this term will be same. Yes or no? This term will be same. Understood? So y square by 2, y square by 2. Substitute the range here. What you are going to get? 1 by 2 into 0 square. So 1 by 2 into 0 square minus of -1 whole square. Yes or no? So what you are going to get? So here 1 by 2 minus 1 whole square is 1. So you will get -1 here. So here you will get 1. So everything is same here. Everything is same. But what is the only change? What is the only change? Tell me. What is the only change? Polarity or not? Here we got what? 5 microcoulomb, the total charge. Now here you are getting what? 5 into -1, that is -5 microcoulomb. That is -5 microcoulomb. Understood? Now if the range of y, if the range of y changes from -1 to 0, -1 to 0, if it changes to -1 to 0 instead of from 0 to 1, then you are getting the total charge as what here? -5 microcoulomb, -5 microcoulomb. Understood? Okay. So in the previous case we got 5 microcoulomb, and in the second case we got what? We got -5 microcoulomb here, -5 microcoulomb. Understood? Okay. Okay. Yeah. Now, okay. So now we try to solve some problems on cylindrical coordinate system here. Cylindrical coordinate system. Understood? So in cylindrical coordinate system, the differential lengths are nothing but d rho, a rho cap, rho, d phi, a phi cap, dz, az cap. Okay. So the differential lengths in cylindrical coordinate system are nothing but what? Are nothing but d rho, a rho cap, and rho, d phi, a phi cap, and dz, az cap. Understood? Okay. So these are the three differential lengths. Now what are the differential areas we got here? dA1 bar is equal to what? Is equal to, so we have done the cross product between these two. Yes or no? What we got? Rho, d phi, az cap. Yes or no? Next, we have already done all these things here. In the previous session I have done all these things, how we got these differential areas and all. Okay. So if you do the cross product between these two, you are going to get another differential area, that is rho, d phi, dz, a phi cap cross az cap is a rho cap, and another differential area dA3 bar is equal to what? Is equal to dz, d rho, a phi cap. Understood? Okay. So here the total surface area we got it as what? If you vary only rho and phi, we got the surface area here is nothing but what? Is nothing but surface area of a circle. Understood? Okay. So if you integrate this with respect to rho and phi, you are going to get the surface area of what? The surface area of a circle. So in the previous session we have seen all these things here. Understood? Okay. Next, for this one here, what are the variables? Phi and z. Here rho is constant. So we call this plane as what? Rho equal to constant plane. So if you keep rho constant and if you vary phi and z, you are going to get what? You are going to get the curved surface area of the cylinder. Right? Okay. Next, similarly here, what are the variables here? Z and rho are variables. Phi is constant. So we call this plane as what? We call this plane as phi is equal to constant plane. Understood? Okay. So now here, what is the surface area we are going to get here? What is the total surface area we are going to get? A3 is nothing but what? Is nothing but you are going to get the surface area of a rectangle. Okay, so I will draw like this here. Wait. So okay, if you vary rho, here variables are rho and z. So this is rho and this is nothing but z. Okay, so this is rho. So if you vary rho and z, this is the surface area you are going to get. So this shaded region is nothing but what? The surface area of a rectangle. So if you vary rho and z, this is the surface area you are going to get. Understood? So these are the three surfaces that we got in what? In cylindrical coordinate system. Understood? So if rho and phi are variables, the surface area is nothing but what? The total surface area is nothing but represents the circular disc. And if the variables are phi and z, then the total surface area will represent what? Will represent the curved surface of the cylinder. If the variables are z and rho, then the total surface area is nothing but what? Is nothing but surface area of a rectangle. Understood? Okay. Now okay. Now if I consider a small differential area, if I consider a small differential area on the surface of the circle, this small differential area is nothing but what? Rho d phi. Understood? Now similarly, if I consider a small differential area, on this curved surface of the cylinder, so what is this small differential area? This small differential area is nothing but what? Rho d phi dz. Yes or no? Similarly, if you consider a small differential area on this rectangular surface, so what is this small differential area? This small differential area is nothing but what? Is nothing but dz into d rho. Understood? Okay. 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 So now I will give you one example here. Okay, we try to determine the so if the charge is distributed or I will give in this manner. The charge distribution on a surface is given by rho s. Rho s is equal to sin square phi by 2 rho. Okay, sin square phi by 2 rho microcoulomb per meter square. So what they have given here, the charge distribution on a surface is given by rho s is equal to sin square phi by 2 rho microcoulomb per meter square. Okay. Wait here. You can write in this manner here. The charge distribution on a circular disc here. The charge distribution on a circular disc of radius rho is equal to 4 meter. Understood? The charge distribution on a circular disc of radius rho equal to 4 meters is given by rho s is equal to sin square phi by 2 rho microcoulomb per meter square. So then determine the total charge. Determine the total charge that is present on the circular disc. Okay, so what they have given here, they have given that the charge distribution on a circular disc here, the charge distribution on a circular disc of radius rho is equal to how much here? Rho is equal to 4 meters is given by rho s is equal to sin square phi by 2 rho microcoulomb per meter square. So then determine the total charge. That is present on the circular disc. Understood? Okay. So consider a circular disc here. So they have given that there is a circular disc. What is the radius of the circular disc here? The radius of the circular disc is 4 meters. Yes or no? So the radius of the circular disc is 4 meters. So on this the charge distribution is given as what here? Is given as sine square phi, by 2 rho microcoulomb per meter square. So this is the charge distribution here. Understood? Okay. Now you want to determine what? You have to determine the total charge that is present on this circular disc. You have to determine the total charge that is present on this circular disc. Understood? Okay. So whenever you see a circular disc here, okay, on the circular disc here, what are variables here? What are variables on this circular disc? What are variables? The variables are nothing but what? The variables are nothing but rho and phi. Yes or no? So if you vary rho and phi, that is going to form what? That is going to form the surface area of a circular disc. Understood? Now here the rho is varying from where to where? Rho is varying from 0 to what? 0 to 4 meters. So that means they have given the range of rho, it is varying from 0 to 4 meters. Understood? And what is phi range here? If you want to consider the total circular disc, what is the range of phi? Range of phi is from 0 to 2 pi. Yes or no here? Okay. So whenever you consider circular disc here, okay, so what are the variables on a circular disc here? How you can form circular disc? By varying only rho and phi, So here the variables are nothing but rho and phi. Now here rho is varying from where to where? From 0 to 4, and phi is varying from where to where? 0 to 2 pi. Understood? So if you consider a small differential area on this circular disc, dA on this circular disc. So how you can write this small differential area on the circular disc here? What are the differential lengths? On the circular disc? What are variables? Rho and phi. So multiply the differential length along rho. Is nothing but what? D rho. Multiply this with differential length along phi. What is the differential length along phi? That is nothing but rho d phi. So if you multiply these two, this is going to give you what? This is going to give you the small differential area on the circular disc. Understood? Now if you want to determine the charge that is present on this differential area dA, is nothing but what? Is nothing but rho s into dA. Yes or no here? So rho s into dA is the charge that is present over this small differential area dA. Understood? Now if you want the total charge here, you have to integrate with respect to what? With respect to, here the variables are nothing but rho and phi. So you have to integrate with respect to what? With respect to rho and phi. So then you are going to get what? You are going to get the total charge. Now here, wait here. Okay. So this dA is nothing but what here? This dA is nothing but d rho into rho d phi. Yes or no? Rho s they have given as what? Sine square phi divided by what? Divided by 2 rho. Understood? Its units are microcoulomb per meter square, and this differential area units are meter square. So here meter square will get cancelled. So finally you are going to get the answer in terms of what? In terms of microcoulomb. Okay. So now do this integration here. What you are going to get? Tell me. So rho is varying from where to where? Rho is varying from 0 to 4, and phi is varying from where to where? 0 to 2 pi, and rho s is nothing but sine square phi divided by 2 rho, and this differential area is nothing but d rho into rho d phi. So I am writing rho here and d phi here. Understood? Now here this rho will get cancelled. Rho will get cancelled. Understood? Now integral d rho here. I am doing the integration with respect to rho. So integral d rho is nothing but rho. If you substitute the range, that is rho is from 0 to 4. Understood? Next, what is left out here? Integral phi is equal to 0 to 2 pi sine square phi divided by 2 into d phi. Understood? Okay. Okay, yeah. So what you are going to get, if you substitute the range here, you are going to get 4 here. I am taking 2, this is sine square phi, na? Okay. So I am taking 2 outside the integration. So you will get 4 by 2 here. So now here integral phi is equal to 0 to 2 pi. This is sine square phi. I can write it as what? I can write it as 1 minus cos 2 phi by 2 to d phi. Understood? Okay. So if you do this here, if you do this, what you are going to get? Here 2 1s and here 2 2s. Okay. So you will get here 2 into integral phi is equal to 0 to 2 pi. Phi is equal to 0 to 2 pi 1 by 2 d phi, 1 by 2 d phi, yes or no, minus 1 by 2 integral cos 2 phi d phi. Its range is from 0 to 2 pi. Understood? So what is this integration here? What is this integration value? That means if you integrate cos function or sine function over its full time period, what you are going to get? You are going to get 0. Yes or no? So this term will go to what? This term will go to 0. Understood? So what you are going to get here finally? So 2 into 1 by 2 into 1 by 2 integral d phi. Integral d phi is nothing but phi. Its range is from 0 to 2 pi. 0 to 2 pi. So 2 will get cancelled. You are going to get what? 2 pi microcoulomb. You are going to get 2 pi microcoulomb. Understood? So whenever they have given the problem like this here, whenever they have given the problem like this, first of all you have to identify the surface. You have to identify the surface, and you have to understand how this surface is formed. What are the variables on this surface? Okay, you have to understand how this surface has formed. What are the variables? What are the variables on this surface? Okay, so if you are clear with these things, then you can determine this type of problems here. Then you can easily determine this type of problems. Understood? Okay. Okay. So, okay. So today I am winding up this session here right now. Okay, right now I am winding up this session today. So tomorrow we are going to start spherical coordinate system here. We are going to start spherical coordinate system. Okay, so tomorrow we are going to start what here? We are going to start spherical coordinate system here. Okay, so today I am winding up the session here. Today I am winding up this winding up the session with this problem. Okay, so tomorrow we are going to start spherical coordinate system here. Okay. Okay, yeah. So daily EMT lectures will start at daily 4 p.m. here. Daily 4 p.m. in YouTube session. Understood? Daily. Okay. Okay, yeah. So I am winding up the session here. Okay, man. Okay. Take care. Bye bye.